Well, hi, good morning. Thank you so much for coming and spending your time with me while I work in my shop here on this radio. Today is the 29th day of December, just about the end of the year. And the weather forecast here, you would think I'm in Canada, it's going to be snow. No, the forecast today is heavy rain, potentially record-setting amounts of rain, not here where I live, but other parts of Ontario, in fact. And yeah, that's winter. So, about this radio, I couldn't even remember what had happened. I had to watch a bit of the last video to remind myself. Right, and I tried operating this radio and had terrible distortion, sounding like one of the tubes is in cutoff, is what it sounded like to me. But you see, and first suspicion is these bias batteries, one of which I tried to rejuvenate here, which we will test and see. It's been about a week. Let's see if it's still got any juvenation in it. And this guy, which I can't remember now, and my voltmeter has wandered off into another part of my house. I was going to test it quickly and see about replacing this, or even just getting rid of it, which apparently is a satisfactory repair or restoration step in many cases. You can just get rid of these batteries and the result is still okay. I gotta go get my voltmeter here. Okay, let's check these two batteries out. This is the one that I attempted to recharge. 1.2, so it's still working. And how about this guy down here? Well, ooh. Looks like 1.1 is what it is. So they're not zero. Now, these batteries are commonly in these radios. These are not. This is a pretty weird thing to find somebody did. Will this pass the signal the same as that? You got to think whoever did this had a pretty good idea what they were doing. So I think it's very unlikely that putting this in would kill the radio and the guy would just leave it like this and go, well, tried it but it didn't work, just leave it all there. He would go on to try something else. And what we're dealing with here is terrible distortion in this radio. When it operates, it really sounds like the A tube or some tubes are running in cutoff, and the signal is occasionally overcoming the cutoff state, and the tube is briefly conducting. We're getting sort of a clicky, poppy, buzzy kind of sound out of it. So what to look for next in this deal? I suppose maybe we can go stage by stage, starting with the output stage, and feed it a signal somehow and hear what it sounds like. And then if it sounds fine, it's not that stage, and then just keep moving back through the radio. In fact, really, come to think of it, the way it sounded is probably an audio thing. That would be my guess. Something going wrong in the audio stages. So what would be helpful is schematic. Did I find a schematic for this radio? And the output tube is, I think that's a rectifier tube there. This looks like a great big rectifier tube, and I think this is the output tube here. 41M in the Rogers number system, not in your usual tube numbering system. So I'm pretty sure if I turn to my tube testers and try to dial up a 41M, no, that's not happening. But these same tubes have let's call them regular counterparts with regular tube numbers on them. So okay, if that's the output tube, it's located right up in here. We could poke around, check some voltages on it. Pretty unusual right there. What is that? What is that? Let us take a closer look here. Give it a moment to focus. What is that? A spring. Okay, so I'm going to stop for a minute and fix the focus on this camera because it will drive us nuts here. Okay, so the focus is now manually controlled, and what am I looking at there? Bunch of wires passing from under the chassis up, and they're going, they look like they are the transformer leads. Almost certainly that's what these are, coming up towards the power switch and the like. So this is up to the transformer, this hole. What is that bare wire coming out of there? That's not normal, is it? Where's it going? Where are you going? So it looks like it's coming and going on there? So it's a terminal on the chassis. This bare wire is going down underneath the other wire. And we don't see it again, but it's probably underneath that wire. I'm hesitant to try moving any of these wires because they're probably too stiff. So if you see a bare wire going to a ground terminal, why does it look like it? It looks like there's some kind of shrink plastic on it. It's really weird looking. What am I to conclude? This bare wire, look at this ball of, it looks like melted insulation. Yeah. I don't know what I'm seeing here. Can't say I've ever seen a bare wire come up out of a transformer hole like that. And what's that ball of stuff right there? Let me pick at it a little bit. Let's see what it is. Okay, let me move this other bare wire here. It's very hard to see with just eyeballs looking in here. And it looks like that blob there is part of this blob here. Is this dripped? Where would, well, the radio's normal position. This would be hanging downwards. This drip would be hanging downwards. And then we have like this thing, which has a very similar it's trying to tell me a story here, but I'm not getting it. A lot of these transformers are filled with a black compound which can leak out if it gets hot and would come down and drip. You know, it would drip onto the bottom plate. Let me look. Let's see what's on the bottom plate. Now, have a look at this. Okay, so out of focus, here's the bottom plate. This would be the area right in here. So we have wax, which has been dripping probably off a capacitor. We got this stream of stuff. It just looks like wax. And then we have this creature here. This could be a very interesting material that will shatter under sudden impact, but will flow over a long period of time. So I think that's a compound dripping out of the capacitors. The other part of this is really stained with something too. Some kind of attack has been going on here. Looks like liquid, literally flowing out here. Now, is there more? This could be on two different ways. This has a edge cut back here, not on the other edge. What the heck is that for? So it could go like this. These holes I don't think are dead center. Or it could go like this. Just the holes seem to be lined up. Try it this way. Yeah, this is probably dead center. So we can't tell front from back. What's this cutout for? Don't know. Don't know which way this went. Offhand. So this drippy stuff here, including this, has probably come from out of this area. I don't know. Not really adding up for me. I'm not getting any useful information out of that. Interesting deposits. Well, what to try? What to try? I did say feed a signal into the output tube and see what it sounds like. But really, checking voltages would be a more sensible thing to do, I think. I go through and check for B+ throughout the radio. I'd probably find it very low on one of these tubes, and that's probably causing the problem. Something like that. Yeah, I think that's what the next step is, just to go through and check voltages. So I found a copy of the schematic on Radio Museum, so let's have a look at it here. It certainly appears to match the radio I've got. It's got the right number down here. That noises you're hearing in the background are my two little cats wrestling, in case you can hear that. Okay, so let's look at the notes and stuff that's on here. Get kind of familiar with the whole schematic. So we have so these are alignment instructions written up here. Okay, here's some nice diagrams showing the coils. Dummy. Oscillator coil. Voice coil, DC resistance. Field coil, DC resistance. And then, so 25 or 60 cycle. Observed line drain. Must be talking about the wattage here. Observed. So we have a, so the power is connected just to the primary and nothing more. And we have, what are they showing here? Grounded center tapped transformer producing 6.3 volts for driving the tube heaters. This guy has his own heater winding here. Probably a 5 volts here for the number 80. This, what is this? There's another one here. What are these? I don't know. I don't know what those are. 16, 25. Oh, C22, C23. These are probably the large electrolytic capacitors forming part of the filter circuit. They're in the right spot here. So that's what those are. Just two. I think there's three in the radio though. So maybe bypass. Here's the. No, look. On the output tube there is no cathode resistor. So down here in the power supply they're pulling a stunt to derive a negative voltage. So the bottom, if you look at it this way, the bottom output of this is not tied to the chassis. It's tied to some resistors that are below the chassis, right here. And so relative to the chassis, you're able to derive a negative voltage, while everything else is positive. It looks like 14 volts. So this is not how many tubes are biased in these radios. They're more commonly biased with a cathode resistor. So the cathode is actually biased, not the grid, but not in this radio. In this radio, the grid is biased at minus 14. So, and this should be pretty rigid voltage. So we should find 14 volts here. What? So 140 volts written here. I answered my question without asking the question. What is the B plus? 141 volts here. That says 141. This says 245. 245. I'm not sure what they're writing there. It looks like 145 volts. How do you get 245 here and 145 here? I don't know how that works. 140. What happened here? I mean, usually this voltage is going to show up on the plate here. So maybe I'm misreading this. Let's go back here. Any plate voltage written there? Asterisk. It has an asterisk. I think that's an asterisk. What's that for? There's nothing else on this page. Okay, don't know what that is. Here's a voltage, 142. See, it's kind of odd, like usually you're going to get like a plate voltage like this on these tubes, maybe a lower one on this tube, but on this tube you should be getting the full Monty out of the power supply, which would be this 245, which is what it looks like. But they got 140 written there. So let's see, this interesting how they've drawn the inside of this tube. We have a screen here, we have a screen here. It looks, I can't read it. 160, 90. I can't read that, what that is. So there's something funny going on in this tube. We see the heater and then the cathode. Then we have a grid number 1 if you like, and it looks like it's connected to the oscillator coils here. And then the next thing would be a screen operated as a plate, as a leaky plate, but they've drawn as a solid line through here. And they're showing 100 volts on it. So this is the oscillator section. Why they've shown this solid, I don't know. The next thing is a screen. See, there's something different about this tube from other tubes, because this screen and this would be the same thing. There's something unusual about this tube. And so here's the signal coming from the antenna onto grid number 1, 2, 3, 4. So usually it's grid number 3. Yeah, something odd going on. And then no suppressor grid in here, but we need to have 100 volts there. It looks like 90 volts here and 142. So they're all written on here. How about the voltage here? 90 volts here, 142. So we should be able to hunt these down. This, I don't know what happened here. Oh, here's the voltage here, 80. 80 volts. Yeah, we can check them all. And they got the pin numbers here. 1, 3, 4. I'm sure that's what that is. 2 and 7. 2 and 7 are typically heater pins on these tubes. Yeah. And 8 is often the cathode. Yeah, just as it is. But the numbering is not sequential around the outside. Don't be fooled that way. Okay, I think we can do this. We'll just start looking for these voltages, and I think I'm going to print this out so I can mark down some information on it. And then we will do that. While I was casually studying the schematic here and just getting ready to do the voltage tests, there was a crash. I looked behind me, and my cat has arranged a new project for me this afternoon, and here it is. The project is called Pick Up All Your Drills Off the Floor. Oh, for crying out loud. Nicely organized set of drills, not so organized anymore. But I bet you there won't be a cat back in my shop for an hour, because that was quite a crash. Okay. Do you have cats? Stuff happen? Dogs? Stuff happen? Even a hamster. Okay, so we were looking at this interesting thing here. I'm pointing at it, this wire here. You can see some heat effects on the chassis just above it. There's actually a hole. No, that's not a hole. Grommet or something. I believe this to be a resistor. Was it ever covered? I don't know. I don't think so. I think it's designed to get pretty hot there. Can't find it on the schematic though, which is what I was looking for when the crash occurred. So let's carry on here. We'll start with the output tube, and we'll just work our way around and just work back tube by tube and see what we get. Here's my voltmeter lead, and the voltmeter I'm going to be using is this guy over here. Maybe if you come down a little bit, you get a better view. This junk in between. Okay. Little practice session here. So I want to start with the output tube. And where did that go? This is the output tube up in here. And the first pin I want to do is going to be pin number 3, the plate. Pin number 3, the plate. Okay, and we look in here with pin number 3, 1, 2, 3. This would be the plate here. We see a capacitor connected to it. A lot of weirdness going on here with some weird looking wiring. Coming to what looks like big whopping capacitor connection here, big filter capacitor or something. I don't know, not making 100% sense to me, but that's okay. Let's just check again. 3, 1, 2, yeah, 3 is there. So that would be the plate, and then there's a screen, which is next one over, 4. So those two I should find high voltage on, 140 volts and 245, which doesn't quite make sense. So that would be 140 here and 2. Looks like a capacitor tied right between them. Yeah, there it is. That capacitor is tied right between the screen and the plate. Okay, made some sense. I think we're ready for that. Here we go. We're plugged in. I want the volume to be minimal. I want the set on with the volume minimal. This does look like a brand new, big brand new switch. Here we go. We are on. Is there a light in this radio? Maybe not. How do you know it's working? Got 100 volts on it. Let's take a look at, so I'm on the DC positive setting here. What is going on the top of this crazy thing here? This crazy thing. So that's 75 volts there. Just watching to see if it's steady. It's very steady. It's not going up. Okay, the other capacitor is oh, it's hooked here right here too. Both capacitors direct parallel here. See, there's two leads coming out of this capacitor, one going over to the top of this one. That doesn't quite make sense. This wire doesn't look like it's the right length. They would tend to cut the wire shorter and bring it straight across. And this has gone, I don't know what's going on there. Something a little odd. Let's check again. So how am I ever, if this is 75 volts right on the power supply, where am I going to find 245 and 140? I am not. And the supply voltage is 100. It's a little low, but not low enough to account for how low this is. Okay, let's do the plan. The plan was pin 3. Pin 3. I'm trying to keep my arm from getting in front of the camera. Pin 3. This be pin 3 here. So I could hear that in the speaker. 75, same as what's here. And then the next one over, well, it is the same as it's right here. It's the same connection. Something funny going on in this radio. Why, we got this big capacitor. That's a third one. Now this looks like it's whipped in, and it's coming over to a connection here. It's not to the ground. It's not to the chassis. It's gone to. So let's just like this capacitor is insulated from the chassis. This one is not. This is on. Don't forget, Jim. Well, we've run into a big problem already. It's just not producing the kind of B+ it should be producing. We have 3 capacitors all positively connected here. How's that helping anything? 3 of them in the same spot. Aren't they supposed to be on either side, like a pie, on either side of the field coil? Again, whoever, either this is the dumbest idea you've ever seen, putting this battery in here, or it's a very clever implementation of a modern solution. If it's a clever implementation, I shouldn't expect this to be nonsense. But if this is somebody's crazy idea, it's not really crazy. Somebody's long shot idea, maybe they munked this all up. Because if we look here, we will see, this is complicated how they've shown this. Let's see. So where's the field coil? This would be the field coil. So we see coming out of the rectifier right away, capacitor, field coil, capacitor. So that's the pi thing. How would the positives? Those aren't positive. They have to be positive. This capacitor, the negative is tied right to the chassis. So who's that? So that's this guy here. This guy's not tied to the chassis. So what is it connected to? So the negative, there's a wire, so there's a wire coming from the negative side of this isolated capacitor, traveling through here, picking up this terminal where this guy's been. So this is an augmentation imagination, but every time I tap on this, I think my shop spotlight here is flickering. If that's the case, I would see it on this meter here. Which, if it were the case, then I should stop doing this. Well, see, that moved. I think it's a coincidence. So somebody's trying to augment this thing. Why? So what's going on with this connection though? And then nothing's on the other side of the. Something wrong here. I'm gonna cut the power. Something ain't right here. We have to find the leads coming back from the speaker field coil and see where they're going in this radio. Easier said than done. Okay. Nobody has any business doing that to the field coil and the power supply. Well, why would somebody do that? We have to remember that if you just go back 20 years or so, obtaining schematic information for a radio like this was such an arduous task that people would work on them without schematic information. So a lot of bad things could happen under those circumstances. Field coil is up here. Wires from it. Popping through the chassis down under here where they can't really be seen, at least not easily. Okay, so I see quite a number of wires coming through there. A couple of them are heading this way. Over to here. So one of them's meeting up with this point. Well, is it? Oh my gosh. Tracing it very carefully. Yes. Yes. Definitely. It's this light colored wire. And then there's another wire very similar to it coming over and going to ground. Well, that doesn't make sense, does it? No, that makes sense. That doesn't make sense, does it? Yes, it does. So the other field coil to ground. Maybe I have this turned right around in my head. But that's definitely a chassis connection. So I don't know what's going on. It looks like this is not part of the filter. And the positives, I have to stop and look at this a little bit closer, I think. Yeah, I don't want to do this on, I'm just going to drive everybody nuts if I keep doing it this way. So I'm going to study this on my own and try to resolve what's going on while I drink some coffee. Okay, I never actually picked up my coffee cup now that I think about it. So looking at this and thinking about it, it's supposed to be 141 volts right here, right on the output. How you get 245 here, I don't know, because right up here it says 143. So this is a false number. I'm just going to assume this is a false number here. It's really throwing me off. So going back to this, the expected output of this arrangement is 145 or 143 volts, but I'm finding 70 volts, 75 volts. That's just about exactly half what's supposed to be there. Half. Half. Well, maybe half this tube's not working. Maybe half this transformer's not working. So I'm going to test this tube at this point and eliminate that as a possibility of what's going on here in this radio. If it turns out we've only got half a transformer Wow, I'm not sure what we're going to do here. Now this is a number 80 tube. Number 80. I think this was made by Rogers. Yeah, Rogers. Licensed by Thermionics Limited, Canada. And looks okay, but let's, that doesn't say much. Let's put it in the tube tester here. We're going to give it a shot. Number 80. Number 80. Over here. Here we are, 80. 5 volt for the filament. JR 03000 03000 0 bias 20 if we care to use the English, which I think we have to in fact. P3 okay, 4-pin. Go. This is on, eh? Let's see. Oh yeah, both heating. Both sides are heating. Okay, I have to watch out or I'm going to step into all these stuff that's on the floor here. Okay, any shorts? Shorted rectifier tube would be bad news. P3 rectifier in the good. That's half this tube. The other half we get to by changing this to 15. Oddly enough, and the 3 becomes a 2. That's all we do. P3. Oh, let's do this just in case. P3. Same as the other side, my button's a little... Yeah, I think it's just the contacts in here aren't the greatest, but it gets up in the good. This is not the cause of our problems. So that's a little disappointing because another possibility is this is the cause of the problem. So we're going to have to investigate that. Maybe I'll leave the tube out for now. I think this is a good way to do it. And we will look for the output voltage of the transformer itself. What is it supposed to be? It's not going to say. So I can measure it right across the whole thing or measure it to... I can't measure it to the chassis because I'd be measuring it through these resistors here. So I really have to kind of get on to these leads. Well, this is the negative lead of the one capacitor, the isolated capacitor, so that's an easy one to find. And then I measure pins 2 and pins 3 where the 80 goes, and I should see similar output from the transformer has, and probably something like 200 volts, something like that. Okay, and with the tube pulled out, this is just cut right off. 2 and 3. Now, how do you recognize pins 2 and 3 on this? So I think you take the fat pins and you go 1, but I'm not sure about that. I'll probably just test the different spots, or maybe I can. Let's turn this right upside down here like this. Okay, the rectifier tube came out of this socket here, so pretty easy. Now the 2 fat tubes, this is easy to do, Jem. The 2 fat tubes fat pins are the heaters, and the 2 thin pins are the 2 high voltage pins. Very easy to see. Well, there's no wire hooked up to one of the pins. What is going on here? Okay, so the radio's not plugged in, so I can still poke around. So you can see the tube here. Let me use the other camera. I think it would just be a little easier. Okay. You never know what you're going to come across in these radios. So here's the rectifier socket with the tube missing. So you can see through. You can see a terminal connection there and there. And where's the connection here? The wire come off and it just flopped over here. Did somebody try? Is this the sign that somebody tried to accommodate a broken transformer, power transformer? Is this a trick? Somebody's trick? Turned it into a half-wave rectifier? I don't know. Okay, I'm going to try to grab those wires. It's hooked up to nothing. Really? Come on. I'm supposed to believe this wire just popped off? From there? Really? Look at that terminal there. It's got some stray strands on it. Again, that's not something you see in factory work. Stray strands are suicidal in these radios, so I'm sure if somebody did that and it looked totally visible, they would get a talking to. For sure, for that. So that suggests somebody soldered. Well, they tried soldering this other wire, but there's no wire. There's no conductor sticking out. How would it come off there? I find some pretty weird stuff in these radios sometimes, and I'm going to try to pull the wire into a little bit of a better position here. Really, why would it get this way? Why would this happen? I don't want to bend this wire too much because it can crack the insulation right up in here. And I'd rather not have that happen. So either this has popped off or somebody has cut it off on purpose. The smart battery guy has cut this wire off. And then what? He cut it off and just let it go? It must have popped off. How could that be, though? I mean, it just doesn't make sense. How that could happen. Well, somebody cut it, and they did just let it fly away. They don't care. Why would they do that? A defective transformer. A transformer with a short. Transformer with a shorted winding. And what they tried was, we'll cut it free right at this point and see if the set gets enough juice from just half. Oh, that would be probably humming too. Well, so what I should do is try to read the resistance through here, because they gave it somewhere here, didn't they? Field coil, voice coil. No, they did not give the resistance through here or through here. But there should be something there. If it's open circuit, then I know we're fried. So I should get my ohm meter out. Yeah, forget about doing voltage tests. Get the ohm meter out and clip one down here and the other there and there. We'll see what we get. Very good. Okay, so one goes to the this isolated capacitor negative terminal, which is here. And then the other one is the two small pins. Here we go. This is the one that's connected. We get about 500 ohms, and this is the one that is not connected. Wait a minute, that doesn't make sense. I gotta touch the wire here. Okay, trying. Ooh, we're getting nothing. If I'm gonna reconnect this wire, I have to cut it back anyway, so let's cut it back. So this is getting to be a bad journey for this radio. Okay, got some conductor exposed there. Put this back where I want it, here. Okay, double check by repeating the last test, getting 500. Checking this wire. Oh, there's the answer right there. I already touched it. Oh! Oh! 500. So, you know, the only conclusion I can come to is the wire is popped off. Maybe during installation it was weakened something terrible. This is a pretty strange finding. If I stick that wire, oh, I can hear the insulation cracking. So I'm trying to get the wire there without bending it. These cloth covered wires, if the insulation is cracking, it's not the cloth, it's the rubber underneath, or whatever it is they used. I think it's a rubber or a plastic sort of material, and because of the cloth, you can tolerate a fair bit of that. That's probably one of the reasons why these radios with these cloth covered wires are still around today. Okay, I'm going to put that on the terminal. Well, why else could this have happened? Boy, I tell you, I like to make up stories about these things. I always feel better when I can tell myself a story about how things got to be the way they are. I guess that's kind of a general rule for all of us, isn't it? We kind of like to know the background on things. I guess it gives us a more solid feeling or something of that sort. If we know how things got to be the way they are. Okay. Solder this guy on. What's that? So hear sounds coming out of the speaker? No, must be my imagination. Once in a while that can happen, you know, you bring out your soldering iron and you can get sounds. Okay, that's soldered up. Let's check and see. Yep. Okay, so what will happen this time if I operate the radio is instead of 75 volts, it's going to have, you know, it's 150, 140. And that'll be the first time some parts are getting that voltage here in my shop. And they may complain about it. So put the tube in. That would be a good idea. Yeah, this definitely goes in the book of strange things I have found in radios. I think I'm going to tip it up because if smoke's going to come out of it, we're much better off trying to identify where it's coming from this way, if that's going to happen. So we have the volume turned down, and we are ready here. Do I need to be testing? Yeah, I'm going to want to test that voltage. So we're going to read from the chassis the voltage on the top on this point, the supercapacitor point. And we should see over here, this thing should go all the way over on this setting. So I'm going to put it on 500 volts. So it's only going to come up to about like this. No, let's make it more exciting. I'll put it on the 150 and we'll see it go right over. Going to have the dim bulbs in, and I'm going to relax the supply voltage a little bit, and I got to plug it in, and I got to make sure it's set right. So we're going to up the volume a little bit, and this is without an antenna connection. It's really not a concern right now. Here we go. Hit the switch. Anything bad happening? Anything bad happening? Whoa, there we go. We got lots more voltage. Maybe this will end the distortion. Is it jumping around? Just me. Okay, how come we don't hear anything? We got voltage this time. Okay, do I remember what pin it was? Touching on the output tube? No, I don't. So we got a tube up here that's easily available. Let's go looking for some B plus on it. No sound at all. Yikes. The last time we had sound. Could be another revision in this radio to accommodate what they... No. The wire broke off on its own. It was a spontaneous failure. Not somebody's plan. Okay, where are we now with the voltage? Still at the same place. Pretty much 120. I'm expecting 140, but we're running it at 90 volts. So up it. In the range of 100 volts. We got 100 volts there now. Now we're... Ooh, there's a click in the speaker. So now we're up 130 volts. We're pretty close to where it's supposed to be. We not have got nothing. Some of these radios are stone silent without an antenna connection. Not this one though. Volume up a bit. Okay, looking for high voltage on this tube. Somewhere, anywhere. Just randomly looking. Nothing there. Ooh, something there. So we got plate voltage on here. And did I hear that? I heard that. Come on, radio, you can do it. I think you can do it. So we're going to hook this up to an outdoor antenna here. First we're going to make sure there's no voltage on it, which there is nothing. Bring this around here. The antenna is not switched on down here, but there'll still be some signal on it. It's a long cable. Getting something now. Pretty low volume, but it's working. That's full volume, but the reception is good. The audio output is low. Distortion's gone because the B plus is proper now. Well, you know what? I think that's good enough for today because it's actually late in the morning. It's actually the afternoon. So I'm going to stop at this point. Excellent. Okay. Found a weird thing, unexpected. I never would expect that kind of... Check to make sure the transformer's still connected. No, that's not on the list. That is not on the list. Well, maybe it's on my list now. Very good. Okay, making headway. And we heard the radio actually work, which is a really good sign. That means the chance of getting it to perform properly is just about 100% now. Excellent. Well, thanks a lot for watching today, and I got to get ready for some very heavy rain that's coming. We're getting warnings from our government weather service to prepare for flood level rain. Just not here where I live, but near here, not far away. Okay, see you on the next video.